Welcome everyone. We are live from Austin here. Actually, I'm the only one in Austin, but and we have people all over the world. We have approximately 128 people right now. Today is our first series on Gen AI Tech Talk. We have a full team of ML engineer here. The speaker today will be Anthony Ruiz, is ML engineer, Otavio, another ML engineer, Yuri, who is our SVP of engineering, Chris, and myself, Chris Hart and myself. So let's give it a start. We have a lot to cover. And I think so we have a packed agenda, right? What we've been trying to do is to actually make an agenda that is interesting to people from technical background and non-technical background, and show real things, right? We've been working on AI for 10 years and on Gen AI for almost 13 months now. We've done quite a bit of projects, on the AI side, and what we want to do here is share our experience a little bit and share what we think you can do within your company, and also the impact that it will have for your business. So on the agenda, we'll talk about this a little bit. We'll talk about techniques that you need to understand when you do Gen AI. We'll talk about what Vertex offer on the Gen AI side and the costing modeling. We'll talk about Duet, and then we'll talk about some of the packages that we offer to get you started on the Gen AI side, and just some few, and then a conclusion about what you guys should do next for your business. So that's for the agenda. Again, I enabled the Q&A. Somebody can check maybe if it works. So first, we wanted to talk about who we are, and why. We've been diving into Gen AI. So we are essentially a service company. We are a GCP Premier Partner, and we've been working on the AI side for the last 10 years. And for the last 14 months, we've been working on Gen AI. We've been able to have access to all the early release of Google products. And essentially, we've been diving in, and we've had a lot of fun. And I think we want to share, what we did and our findings. Right? On the AI capability, I mean, this is a slide, we can share that after the meeting, but, we've done a lot of what we call traditional AI, which is essentially custom modeling, and, some historical product that Google has. And then we've done a lot of generative AI, right? As we speak, we have, 7 ongoing projects, with different companies. And we're doing quite a bit of workshop to educate, companies and potential customers. And we've been growing our team. Right now, we have 11 people in our AI team, and we've been trying to make sure that we are actually the best at that. Right, that's kind of our goal. I think. When we started to work on this 14 months ago, we kind of Gen AI was a buzzword. I've been attending a lot of these conference, and essentially it was always like, oh, wow, it's going to revolutionize everything. Yeah. And we were like, okay, well, I don't understand. Let's actually do some project with customers and see what happens. And I think what is very different is you have something that you still do, like custom modeling and custom training, and you have a lot of product that are what we call legacy a little bit. It's still, obviously, you still do that, but there is some stuff that are completely new and some stuff that are very faster and cheaper, right? I mean, for instance, search, is becoming faster and cheaper. Predictive modeling is super easy to do now, thanks to different techniques like AutoML. classification, summarization, extraction, all these things are faster and cheaper to do. And what that means is you can do it in your company for fast and cheaper, right? I mean, so I think that's new, right? And the new things, the very new things, is like all these capability that these LLM have done for us, which is essentially creating text, creating images, creating videos, understanding, pretty complex things like comparing reports, which we'll show today. And that basically brought a series of things, right? A series of new technology like vector database, fine tuning. You have to do cost optimization because LLM are not necessarily cheap, and it's just brought all kind of like new challenges when you develop application, right? The other thing that has been amazing is like you have Model Garden from Google, from Hugging Faces, that are basically letting developers just consume model and easily implement model, and again for cheap, right? So I think it's kind of a brand new world, and we just wanted to show that graphic because like this is our experience, right? This is not anybody else, but it's just new, and so we'll talk about all these things during this webinar. And just to get started, we just want to show one of the few projects that we started with, and I'm just gonna essentially start one of the first project we did for a retail company, and I will share my screen. Hopefully you hear it. So this is a fashion show. Hopefully you see my screen. This is a fashion show, and what we did is we integrated this retailer product catalog to this proof of concept. And what we are doing here, you're going to see like model going through the show, and then with my mouse here, I'm going to be able to zoom in and essentially see what they wear, and it will allow me to buy it. All right, so I'm just going to click on it now. Here we go. Hopefully, it's going to find something, and so here we go. So here you can click on one of the product directly, and it basically allow you to identify what the product is, and then you can buy it, right? So that's one of the first proof of concept we did some few months ago. So again, new things, new thing for retailers, and we'll see some more demo a little bit later. And then I want to hand it over to Anthony, and Anthony is going to talk about content engineering right here.
Okay, thank you. I'm happy to be here. Okay, first, before I can tell you a bit about prompt engineering, first you may be wondering what is a prompt, right? So prompt is basically the text, a text in a natural language format that we send to the generative AI model to request to perform some task or to give some response, right? So that is what is basically a prompt, and it usually contains what is some instructions, some context, and examples in order to provide or to be able to get good output from the generative AI model. In that line, prompt engineering is basically crafting or the practice of designing good inputs for the generative AI model to get the best output that we can get from the generative AI model. Why we want to use some prompt engineering techniques? Well, basically, we want to first reduce hallucination of the LLM, for example. We want to reduce the bias that can be found, and also to have more control and predictability of the outcome of these models. Here you can see a list of different prompt engineering techniques. There are actually more prompt engineering techniques that has been released in the last months. These are like the most common that we are using for building these generative AI solutions. So for example, we have few shot prompting, zero shot prompting, chain of thought, and more. Next slide, please. So you may be wondering how much applying these prompt engineering techniques can impact to the final output of the model. Well, here you can see some examples. The first one is a basic prompt where we want to just generate a reply, let's say for our community, right, of our product. A user gave a review of our product and we want to be able to generate a reply. We can use generative AI for that. But as you can see, this output may be quite long for a community, from a community manager, for example. So we can apply some prompt engineering techniques to try to improve that output from the model. That is the second example. That is the few shot prompt, where we are also provide additional examples of what the output that the LLM should generate for this kind of inputs. In this case, we have this customer review. We want a shorter output, usually with an emoji included, right? So as you can see, we provided 2 examples to the model, and then we are able to get a better response if we are trying to reply for example, to a comment or something like that. In this case, we have a short response with an emoji at the end, right? One additional and interesting prompt engineering technique is chain of thought, where we want the LLM, or we force the LLM to follow some intermediate steps that will help to provide the final outcome or the final result. In these cases, especially when we want to guide the LLM to apply some logics or to think in that particular way, it's when we want to apply this kind of thing. And these are just a couple of them, but there are actually several different technologies or techniques that you can use with prompt engineering.
Excellent, excellent. Thanks, Anthony. So, Ottavio, let's talk about RAG and what that is.
Yeah. So, hello, everyone. And RAG is essentially another technique to steer the model behavior. And RAG stands for Resource Augmented Generation. And it's mainly used to solve the main limitations of large language models in real-world scenarios. So, for example, one very famous limitation of LLMs is outdated information. So, for example, if ChatGPT was trained only in December 2023, it will only know facts up to that date. It won't know any future facts that happened afterwards. So this is a limitation of all LLMs, essentially, not only GPT or Gemini. Another limitation is a limited scope. So LLMs are trained on massive amounts of data, but data sets don't cover every single topic that exists. So, for example, if you have a very niche domain or a more restrictive domain, that means that the LLM probably doesn't know that much about this domain, about this subject. And the third limitation that is also a big one is lack of grounding, what we call grounding. So LLMs are like teenagers, so they're prone to hallucinations, and in other words, like generative, creative, but inaccurate responses. And RAG helps those LLMs by giving it context and actual factual information and statistics and that kind of stuff to improve the ability of the LLM to reference like a a real source instead of relying only on the creativity of the model. Can pass the slide. Yeah. So to explain in simple terms what actually happens in a resource augmented application is a good analogy is to try to think of an LLM like a student and try to think like your vector store, usually a vector database, as a library. So the LLM is like an intelligent student who has read a large amount of books and articles. So, and a RAG is like giving the student access to a huge library, and the books in the library contain up-to-date facts, statistics, and information on specific topics. And this student can answer questions not only about what he already knows, but also search other information on this library when needed. So imagine a student has read a lot of books, but never studied botanic, for example. And you have a library that has books about this topic. So even though the student doesn't know anything about this particular subject, he can look up at the library for the information and answer questions, at least basic ones, related to botanic. And this kind of dynamic occurs exactly like this in a resource augmented environment or application. But, yeah. So how does that work in practice? There's mainly two steps in RAG. One is offline, which is essentially indexing or building this library. So what you do first is create a little pipeline for ingesting that data source and indexing it. So documents, books, or whatever it is your data source is. And this usually happens offline. And the final result is generally a populated vector database to be used by the second phase, which is retrieval and generation, which is actually the actual RAG chain, which takes in the user query at runtime and retrieves the relevant data from the index that you built, the vector database, and then passes that to the LLM as a context to be used to answer the query. So it's a kind of a two-step approach. You can go to the next slide. Yeah. So for example, in the indexing, how did it works, right? Let's zoom in. So first you load the documents that you plan to use as a context for the LLM. That can be PDFs, documents, text documents, JSON, whatever information, websites, whatever information you can, those models can leverage, usually text, right? And you split that information in chunks. You do that because LLMs have a thing that's called context length, and they have a limited number of characters that they can take as input. So it's best if you can break down these large documents into small pieces. So it can be embedded in the next phase, which is essentially turning those texts as in a vector representation that LLMs can understand, right? So LLMs work with numbers in the inside, so they don't understand text by default, right? You have to tokenize it and to embed. And by creating those embeddings, you store them in a vector database. So there you build your indexing or your library, essentially. And in the next step is the actual retrieval generation. So the user comes up with a question for this LLM or for chatbot or LLM-based application. The application takes this question, transforms into a vector as well, retrieves it using vector similarity techniques, which are essentially standard algebra techniques in most of the cases, retrieve a relevant context that is related to the question, passes it to the prompt, and here you can have other prompt engineering techniques to support that question as well, just like Anthony presented. And then this is passed to the LLM, and then the LLM generates an answer that is grounded on these documents that it retrieved from the vector database. So that's the summary of how a RAG system or a RAG application works. And one of the key components of such a application is a vector database. Right now, we have a lot of startups and trying to build vector databases or allowing or existing database enterprises enhancing their existing database with to support vectors. For example, Postgres, you have pgvector, which is essentially an extension for Postgres that allows Postgres to receive to deal with vectors. You have Redis and Cassandra as well, which is our well-known databases, also allowing vectors right now in the latest versions. And you have standalone vector databases, which are essentially they essentially try to stick out as being like very optimized to these types of applications, such as Pinecone, and open source ones such as Chrome. So that's basically it. And the future of RAG systems. So this is like very new things that are developing in this RAG world. Is that with the increasing context window on the LLMs. So for example, I just mentioned that we chunk the input into smaller pieces to be able to put that in a prompt and not blow out the limitation of input token length. But for example, Gemini 1.5, which is the latest model from Google, is not yet released, but it has like a much larger context, so in the millions of tokens. So you can fit entire books, entire documents of dozens of pages, and you don't actually, in theory, need RAG in those situations. Of course, I personally think the need for RAG would be reduced, not turn complete obsolete, at least in the near future. And this is a thing that more and more we're gonna rely less on RAG to have a good performance, because that's a limitation, right? You have to build a database and an indexing system for that. This system needs maintenance and all those complexities. So it's not ideal. So it's better if the model out of the box can have like a huge context, so it can reference your entire documents, especially if you don't have like a huge corpus. You have just a book maybe, or a few documents with 10 pages, 20 pages or so. So it's best to put everything in the context of the model possible, so you don't have to search for that information. So that's where like the research is going to, also in the prompting, not only in the prompting, but also in increasing this context window of models.
Excellent, Ottavio. It's true that Gemini 1.5, is definitely evolving how we work with LLM, right? I mean, we'll talk a little bit about this in another session, but there's some impactful changes.
Yeah.
Demo. All right.
Yeah.
You're doing the demo, so I'm just going to leave that back to you.
Yeah, I'm going to take over the presentation. Yeah, so this is one of the demos we built here at SASMIC, and uses Vertex AI search and conversation, which is a nice and fast way to build RAG applications if you are looking to chat with your data type of application. So this one, we have a few documents that are basically financial reports from a couple of companies. One of them is Alphabet, the mother company of Google, in a cloud storage bucket. And those documents look like this. They are like standard 10K forms from the SEC in the United States, and they have a lot of text. They have like 92 pages, tables, numbers, graphs, all sorts of content. And a use case for that is like, imagine you are a financial analyst or someone looking for relevant information in this huge document. You would have to read the entire thing to know a few details. And what RAG does and Vertex AI Search does is allow us to make questions on this document without having to, read it all and have nice insights. For example, I can ask one very common question, which is, what is the main source of revenue for Google. So this search bar is linked to all those documents, and it must understand that Google is a company under the Alphabet company and such. So RAG will greatly help here. And under the hood, it uses Gemini to generate the responses and actually give Gus a very good response, which is Google is the main source of revenue is advertising, and even sits the document where it took that information from. So it's like having Google for your documents, basically, and with plain text answers to your questions. So you can even follow up and ask follow-up questions. So for example, what's the amount of revenue generated by advertising? And it gives you the correct amount. You can check in the document, but this value is correct. And this is very cool. This is a very standard application, but you can build that only using the Google Console UI. You don't actually need to know how to engineer prompts or set up a vector database. All you need to do is place your documents in a cloud storage and create a data store, which is basically an index for your data, and in a few clicks, and you are good to go. And you can integrate this just like we did here, integrate this search bar on your website or in your internal system. So yeah, that's what I have for the demo.
Thanks, Ottavio. I'm just going to go back to the presentation now. And then we're going to talk a little bit about fine-tuning. So I think, Anthony, this is your section.
Okay, thank you. Well, I would say that, as you could see, as Ottavio showed to you, there are, with RAG and with other additional prompt engineering techniques, we can basically handle a lot of different use cases, right? With generative AI. However, there are some particular tasks, let's say a specific tasks that are, or that can be quite difficult to perform just by prompt engineering, or sometimes we want to get, or we have some specific requirements for the output that we want the model to generate. So in those cases, we can also apply one additional option, that is fine-tuning the model. So what is basically fine-tuning? Fine-tuning is not training the entire model, but only training a few parameters of the model with some specific data set. That can be, for example, internal knowledge of their company, or the examples that will serve to train the model to behave for that specific task or in that specific topic, right?
And Anthony, I think in the slides after that, you have a nice flow chart that explain when we do fine tuning, when we apply RAG and stuff like this, right? So we'll be able to talk about this. So go ahead.
Sure. Just to provide to you an analogy about what is what it means to fine-tune a model. Well, it's like if you're a general speaker, right? Fine-tuning is like teaching someone from one specific profession or job. That is not only learning the vocabulary that is inside that or for performing that specific job, but it's also understanding the logic and all of that connections that are inside. Yeah. Okay. Sometimes we get that question that, okay, so do I need to just use prompt engineering, or can I, or model tuning, or can I mix both of them? Yes, actually you can mix both of them. That means that you can fine tune, for example, you can fine tune an LLM and then use on production that, but a combination with prompt engineering. Okay, so here we go. We have another demo here. Okay.
Let's do the demo.
Share my screen.
And here, the example you're going to show, Anthony, is basically you're fine-tuning with legal document, right? So the LLM understand all legal concepts, right? That's what you've done here.
Yeah, that's right. So, as I mentioned, fine-tuning is like helping the model to become an expert in some, for example, topic. In this particular demo, what I want to show to you is how we fine-tune an LLM to summarize and, let's say, translate legal terms to a non-legal technical person, right? And how we can do that, just to share that with you, we need to generate that data set that we need to provide, right? In the form of input and output. In this case, the input is the technical legal text that we want to be able to translate and summarize to a non-very technical user, right? As you can see here. So we have several examples that we provided to the LLM to perform that fine-tuning process. After that, we have the model that we use and we have available for this demo. So now, for example, we have this PDF that is control flow. As you can see here, there are several terms and clauses here about some legal terms, and we want to summarize the entire document, right? So what we can do is we can use the fine-tune model that the model that we have tuned for that specific purpose to summarize the content. So we have much shorter content that also is translated to non-very technical users in order to help them to understand what is the content about.
Excellent. Thanks for that. Okay, so let's go through the rest of the demo. So I think now we're doing another demo, which is this one. So, oh no, sorry, Anthony, you have to explain when do we do fine tuning, when you do RAG. You go ahead. Yeah.
Okay, so here, this is, as I mentioned, we can combine both of them, but as a general tip, if you just want to start with one of them, this is one path that we want to share with you to decide which technique to use first, right? So that is, for example, if you can start just with the basic prompt engineering to see if you are getting the right results, right? If you with just the basic techniques and you can test your results, if you see that that is not working, you can, for example, try with RAG to improve the content of the model and get the desired outcome. If you have that data available, right? If you don't have that examples or context that you can provide on the prediction time to the model, you may need to automate or to generate those examples, and you can think about fine-tuning the model to be able to give to you that accurate response that you want.
Cool. Let's go to the next one, which is a big topic, right? Like we see a lot of companies that are building LLM and want to do their own LLM. And I think Ottavio, we wanted a little bit to educate people about when we do that and or when we don't do that, right? So go ahead.
Yeah. The short answer is you basically never do it unless you are one of those companies that Ian just mentioned. So Google, OpenAI, Mixtral, those are the types of companies that are selling the model itself or the API to use that model. If you're not one of those companies, you don't actually need to train an LLM in general, right? Because and why don't you do it? Because training is very expensive, time-consuming, requires a lot of GPUs or TPUs, which is a specialized hardware. So you probably will need a research and development team that has expertise on that. And you would train an LLM to perhaps improve your accuracy on some task, right? And you most likely just need fine-tuning. And the other techniques that we showed, like prompt engineering, fine-tuning, and RAG, if you combine all three and use like a good model, a good and like various models like Gemini and GPT-4, you probably will be able to do whatever you are trying to do with LLM, unless your needs is actually to open source and to service that model to other companies. You shouldn't never basically train an LLM from scratch and just rely on fine-tuning RAG and prompt engineering. That's all.
Excellent, excellent. And now we're gonna do what is it we're gonna do? We're gonna do another demo just to show basically what we've done. So I'm gonna show like the dealership demo that we have. So this is a demo that we've done for Porsche as a proof of concept. And the idea is like if you're a consumer, you're trying to maintain your car and you want to make sure that essentially you are in touch with the right dealership and you can schedule an appointment. So here it asks you what is the model of your Porsche. You say, okay, I've got a 911. It shows you the model. It asks you for the mileage. So you input your mileage here. Then and is like basically it tells you what's the planned maintenance you should be in for, and then it asks you whether you want to find a dealership in your area. So you say yes. Here, what it does, it integrates with Google Map. It's going to recognize the fact that I am in Austin somewhere. So you see what is I am in the office, so it finds me the dealership here, and then it gives me the directions, and then it asks me, okay, which day you want to go to, because it's integrated to the dealership calendar. So you pick a day, you say Friday because I'm working hard, so I only have time Friday, but I finish at 2, so I choose 2 o'clock. And then he says, so what is your email address? You say, okay. That's my email address, and then he's going to send me he's going to create a ticket, and he's going to basically also send me a calendar invite to my calendar. And here you see that it creates a ticket automatically for the dealership. And excellent. I'm not logged in, so I'm going to have to log in now. But it creates a ticket for a scheduled maintenance appointment. It tells the dealership which model of the car it is, what time is the appointment, and who's the client, and so forth. So I think that's been something that has been pretty popular as far as POC that we've made and real implementation. So this is what we call the quote-unquote dealership demo. So back to the main topic. So we're already late. I think here, Anthony, we want to talk about the historical AI stuff and what you can do in Vertex AI pretty well, but you still can do, right? So if you want to touch a few words there.
Yeah, sure. So we can see that there are a lot of things that we can do with generative AI, right? But some people are questioning about, okay, but what are the traditional ways we can train models? Well, they are still there. In Vertex AI, we can find 2 methods for training models, right? The most simple one is by using AutoML to train models based on the data format. We have different options available. We can train models for image, for video, for text, for tabular data, and that can be in the form of, for example, object classification, action recognition, entity extraction, regression, classification, or forecasting, right? But also there is the option to perform our custom training jobs, to create our custom training jobs by using the managed training service from Vertex. The steps, as you can see in this diagram, we need to first load and prepare the data that we will use for training. Then we need to prepare the training application, a Python training application, configure a training job, that is where we set up the infrastructure where our job is going to run. And then we just need to create and run the training job. After that, we will see the results in our model registry. And finally, and optionally, we can deploy that to an endpoint, so we can use that for online predictions.
Excellent. I wanted to show quickly another demo before we continue. So let me just do that. Just 1 second. So here, what we're going to show is the ability of an LLM to create reports, to compare reports, and to interpret the comparison of the reports. So as I used to say with Anthony, we thought it wouldn't work, but here what we've done, if you see my screen, hopefully, like we ingested the schema of BigQuery database in an LLM, and what we were working with is a company that has a lot of data about wine consumption in the US, and the use case is basically that they were working with winery. They wanna analyze the consumption of the winery of different wine type, like red or white, and they want to compare that to the US. And based on the comparison, they wanted to have meaningful marketing plan to make more money, essentially, right? So here, what you see is like the LLM doing some queries to fetch some information about the wine consumption in California and in the US, and then after that, like we're basically asking the LLM to do a comparison of a winery with the national, data, and the subsequent step is to take this comparison, interpret it, and make a marketing plan based on that, right? So it's pretty amazing because the LLM has plenty of wine information, basically native to the LLM. So here is basically coming and saying, okay, well, here's the comparison. Like you have differences in wine consumption in red or white, and then we're asking the LLM, okay, well, what can we do to improve these numbers at my winery level, and what kind of strategy I should ask for, right? So he's like, oh, okay, you can focus on sparkling wine. You can have signal marketing strategy, partner with our business, and so forth, right? And in the real case, we had a lot more specific because obviously that was the data of our clients, sorry. But it's been amazing because here what you're doing is like you're asking the LLM to generate reports, to compare reports, and then to interpret the comparison of the reports, right? And so that has been, if you want, it's almost AI on AI, right? And it's been able to do that pretty well. And so that's for that, right? The LLM can do much more than just creating text. It can actually create a report, compare them, and analyze them, right? So back to the main slides. Yuri, you wanted to talk about conversational AI, yeah?
Yeah, thanks, Ian. I would like to cover a little bit about background of those demos which Ian did show, and an example of Porsche chatbot. For example, how was it built? In the background, there is the technology called Dialogflow. That's the new way to build dialogue chatbots on top of AI. How does it structure? So you can see the diagram which shows different roads, that different scenarios which could be processed by Dialogflow. And if to compare to standard or classic chatbots, here we use LLM models which analyze the conversation. So user can make mistakes or he can write differently, or he can write on different languages. But having AI behind that conversational chatbot, we can understand what the intent, what the intention that user would like to solve, and we guide him through that conversation flow. And for example, this picture demonstrates how it could be built. And there are multiple possibilities how we could handle those. Because Dialogflow proposes us multiple scenarios how to handle this conversation. We could use standard models like text, Python, Gemini. We can use some more advanced fine-tuned models for our scenario, as well as it combines different approaches. For example, before, Anthony did describe how prompts works. And the same here, we can build our prompts, which will help the AI model to guide this conversation and to move it to the right direction. We can say initial scenario, for example, you are assistant. If we are talking about car appointment, we say in initial prompt, you represent that company. You are assistant and you should help user for his questions in this area. To make it more precise, we can teach LLM by different possibilities. For example, we can index the website. Imagine that is appointment to Porsche car center. And here we can index that website that will allow our model to understand which pages it consists of. And it can predefine some answers based on the public available information from that website. Second approach, we could predefine frequently asked questions. If the goal is to help user to find proper services at our website using chatbot, we can teach the chatbot defining the frequently asked questions. That's called structured data. There are possibilities to define to chatbot unstructured data, which represents itself like files, different formats, CSV, Excel spreadsheets, PDF, whatever company has, or structured data, structured like questions and answers. This way, we will provide user more specific answers how to proceed. And when user is asking about appointment, we can check, first of all, our data source to understand is this answer there from the list of predefined questions. If not, then we turn on or plug the second part, which is called webhooks. We can build our conversational AI on top of webhooks. It means we can call backend, we can call REST API methods and do additional functionality. We can do additional functionality which will calculate something, which will prepare answers to user based on the database data, based on the API we have. And that is what is called webhooks, and that's what makes that Dialogflow chats more powerful. So that is a combination of generative AI, because when we don't know precise answer, we can guess that answer based on provided information. Or it is a combination of the flow where we can guide user through different scenarios we would like to achieve. So for example, these conversational bots can be a good help to companies who would like to solve issues with chain supply or customer support services, because it saves amount of efforts or hours spent by human and replaces that by automatization. And we don't need really human here, because AI helps us to understand what people want. We can understand the intention of the user, and we can guide him through those scenarios. Of course, that's like a new way to build applications, but it's classic. It's still classical way. All of that goes back to activity diagrams, UML, where all the software development began. We build processes. We guide our user to solve the task. We provide different opportunities and possibilities from our web application to solve that task. Yeah, you can move to the next slide, by the way, because
Sure.
I will extend that. So Vertex AI have the possibility to cache data because we support user sessions. It can remember the dialogue. It can remember what was discussed with that user before. We can, depending on the situation or the intention of that dialogue flow, we can define duration of that session. It could be 30 messages, or it could be some amount of seconds, minutes, hours, or even days. So we can define that. And if we support and maintain that session, then our model finds for that particular user faster results and more precise results based on the context. You can compare that with the concierge service in some financial institution like bank, and you have personal banker who knows a little bit about you without your personal information, without your transactions, but he knows what you are doing, what operations you would like to do, and he will help you to find better products, some opportunities, discounts, which will fit you. So that's kind of solutions which could be solved using Dialogflow. And also using some kind of such kind of models like Gemini provide us the possibility to use streaming or messaging, because the answer could be pretty long. And we would like to show users some intermediate results. You all have this experience based on ChatGPT. When you start asking some questions in the chat, you see that it doesn't provide the whole answer at once. It starts typing and gives you an information step by step. If it would be working different way, you would have to wait. You would be not happy, and you will think that that service is very slow. But you see some intermediate results, and you wait, and in the meantime, you read that information. The same is here. Using popular and latest models from Google and using client libraries, we can do the same kind of behavior. We can supply user intermediate results. We can post those topics and messages, and we can show them to user. All of that achieved using Google services. And here, for example, we could use technology called PubSub. Ian, I think you can skip that slide and move to the next one.
Okay. Here we go.
When I mentioned that for Dialogflow, we could use different kind of models, I mean that in first case, we have model garden. Vertex AI service have a variety of predefined models which solve different kind of questions. So, for example, if you would like to build service which will translate text or work mostly with the text, you will just choose one of models from the language category, and you will choose the one which you need, which will solve your issues. If you are interested in a model to process documents, OCR, recognition of invoices, then you probably will go to the category related to processing of documents. If it is working with the speech-to-text, text-to-speech, there are models which helps to do this effectively. There are models like Gemini, which are used for different kind of scenarios. You can use it for describing the image. You can use it to describe the video. You can use it as a generative AI. But in your specific scenario, sometimes it could be more expensive or slower. And that's why you can choose from other models for your particular goals. For example,
the point is, I think Google is making available not only their own model, but they're also having a deal with Hugging Face, and essentially all these models are available to user, ready to be consumed, and they're easy to deploy, into your environment for development and production. And I think that's huge, right? I mean, because 10 years ago, I mean, all this stuff was so hard to do, right? I mean, and it didn't exist. So I think this is really a big change.
Correct.
Cool. Cool. Let's talk about Thank you, Yuri. Let's talk about Dialogflow playbooks. I think that's something that is also very new, and I think is changing the way Dialogflow is used in the development of applications. So, Ottavio, do you want to take that away?
Yeah, sure. So yeah, so as Jan said, Dialogflow playbooks is essentially a new way of building those chatbot applications like you just showed. So rather than defining Dialogflow CX flows, pages, and intents, I think everyone saw the flux of pages and information. So this can be very complex, right? Depending on your use case. And it actually takes a lot of time to design those flows and design those conversation paths that you can take and that you can have on your application. So it should, with the recent advancement on LLMs, you can actually build those same chatbots, but without having to specify those things. And you can use just natural language instructions and some structured data if you need that. And this can significantly reduce the virtual agent creation and maintenance time and enable brand new types of conversation experience for your business. So it's essentially a faster way to get where your standard chatbot application can be and take advantage of LLMs to generate intelligent responses for users. So I would like to show a small demo of bot in Dialogflow playbooks. Let's showcase. Yeah, so in this page, here I just have like a standard website chatbot on the corner, but it's just to showcase the capabilities of the bot. And this is a travel-related chatbot, so I will ask traveling and places to go, stuff like that, to this bot. And how can I help you with travel plans? So imagine I want to visit Fortaleza in Brazil. So what is the best time of the year to visit? So the bot responds naturally, and I can ask tougher questions as well. So for example, what is the language spoken there? And it understands that you mean spoken in Fortaleza, so it's Portuguese, it's the official language of Brazil. So this is a standard, like this is like every other chatbot you know. But the cool thing of the Dialogflow playbooks is that it allows you to build such a chatbot with just by just defining the goal of the chatbot. So this is the Dialogflow interface on Google Cloud Console. And the thing you need to build that chatbot is just define the goal of the chatbot. So if this chatbot, your helpful assistant that assists travelers, questions about places to travel, things to do in certain places, and travel-related subjects. And you provide a few other instructions, so like greet the customer, and if the customer asks questions that are not related to traveling, you don't answer them. And here, just like if you're familiar with LangChain agents, you can pass a tool. So this bot can have access to a REST API to query for something, some other information. Can also consult other playbooks or other agents. So you can build a lot of agents under like a fodder agent, for that matter. And so you only need this instructions, this goal, description, and a few examples. So I inputted here just an example of a conversation, and the way you build it is also interactive. So you just talk with the bot and adjust the conversations and place the language and in what state the bot should end if that conversations go on. And that's that. You just need 2 examples, a brief explanation of what the bot should do, and there you go. You are good to, use this bot right away. And this is the exact same bot I just showed you. And this is like a much faster way of building such chatbots instead of relying on the flows of conversation and all that difficult concepts.
That's amazing. That's even easier than before. Thanks, Ottavio. So
you.
let's continue because we are basically running against the clock. So I think you wanted to show quickly a demo of what you can do with Duet and talk a little bit about what that is. I think we have a good demo there. So go ahead. We're a bit behind on time, but good.
Yeah, correct. So let me share the screen, and I think I will build a demo using Duet AI. And actually, what is Duet AI? That assistant which helps you to solve different kind of questions and tasks. You may see that service very popular very soon, and that's how it works. For our case, for example, for my demo, I would like to build a simple application.
Are you sharing, Yuri? Or?
Yes, I'm sharing.
Okay.
And there is a tool called AppSheet. You can imagine the way to create standard, simple dashboards for some kind of tasks. For example, you can see here, start with the template. What kind of applications could be built with the templates? You can build application for to-do lists, logistics, project trackers, delivery, task managers, booking services, and so on. So that's predefined categories which AppSheet helps to build. And here we can see Duet AI. And it works based on prompting. Hello, I'm Duet AI. I can help you to build an application. Please tell me what you would like to build. Here I have predefined prompt. I will read through it. I need to create an application for clients to submit requests for assistance on their cloud solutions. Time estimated, time spent, comments. Manager should be able to assign engineers to requests. So that's my prompt. The more detailed prompt you will write, the more precise answer you will get. Then I submit that, and let's see what will happen. Before, to build an application, I would have to build some structure for it. But now, while I was talking, Duet AI suggests me the data structure of the data. Tables, columns. I can double check. I can start it over if I don't like it, if it doesn't correspond to my initial goal. But I see entities which we have there and parameters, and it corresponds to my prompt. I create an app, and then what will be next? It sets up that application. It not only will build some code or functionality for me, it will set it up, deploy, and will give me an access to dashboard with the test version of that application, which I will be able to maintain and improve later. So for example, right now, you can see it adds some authorization, authentication. I shouldn't care about that at all. It's done in the space of Google Workspace. That application will have web browser UI and mobile UI out of that box. So it will work well for my laptop or for my mobile device. You can see how my application will look like. If you remember, I asked for the tracking system to create tickets for my DevOps team to fix some issues, to report the progress and track the process. Here you can see requests. It emulates some data. It emulates requests. I can provide comments. I can manage the team of DevOps engineers. I can add clients to that dashboard. I can see the mobile view of that application. I can, and by the way, if I work with the mobile view, it will have built-in authentication. I will have login, logout, forgot password, and so on. I can share that application with clients.
This is amazing. Man. I mean, you know, I remember building these kind of apps, and it would take me 3-4 months. Now you just like ask for something and it does it. Obviously, I'm sure it's not 100% like the real thing, but it's really close, right? I mean, it does the mobile channel, the web channel. So lots of productivity there for someone.
Correct. And now to build that, I didn't have to do anything, just to build a prompt. And I have application. It will work from browser, from mobile application, and so on. So you can see here the browser version, how it will look like. And I can customize it. So I can change the structure of my data. I can define types. I can add some additional tables and columns. I can change the look and feel of that application. I can change views. How will it look like? I can brand it for my organization. I can change colors according to my brand book, and so on. So actually, if I don't like out-of-the-box application, I can customize it. But that already saved me a lot of time because I already have it. I can continue work with that and improving it.
Excellent, Yuri. I mean, that's awesome. I think we should say that Duet AI works with AppSheet. It works with GCP on the DevOps side. It works with Workspace, like obviously on the Workspace side. And next time we'll show some demo for those. But it's a pretty powerful tool, and that saves you a lot of time. So yeah, thanks for that. Let's just go back to the demo. Couple of things. So today you've seen dealership operation, fashion show shopping, AI analytic, and I'm going to show you content search and organization now. This is, funny enough, one of the most popular demo of the most popular application of the LLM, right? When we talk to company, they're like, oh my God. And so the use case here is like, if you have a bunch of drives, right? The LLM is able to look through this drive and essentially tell you what's in there, what's the topic that is in the documents, do a classification, and then do a short summary of basically the document itself, right? So here, for instance, it's an investment. It summarizes the performance of the investment, and it classifies it as e-commerce, right? And a lot of the use case here that we've seen is like, for instance, people want to understand what is in their legal documents, right? So they asked us to same thing, do a classification, extract some particular information from the contract, the pricing, who is the client, and so forth, so that they can look at the thousands and thousands of documents that they have in their drive. So that's the last demo today. So I'm just gonna. Did I not show this? Oh my God, I didn't show this. So this was the demo, by the way. Like this is like I'll redo it really quick, but this is the LLM summarizing what's in a drive and classifying and summarizing all these documents. Sorry about that. Going back to the presentation, I think we want to talk briefly about the packages, right, that we can do for clients. So we have a list of 6 packages right now, but out of the, we can really roll out to customer, like document search and organization, the virtual assistant based on, for customer service based on FAQ and knowledge base. We can do AI analytics, report comparison. We can do a lot of like product catalog integration for e-commerce company, enterprise search, and obviously a lot of predictive analytic models. So these are the list of packages. If you have questions, you can ask. We can send you these packages. Couple of things, since we are at the end of this presentation, there's a bunch of blog and podcasts that we listen to. Here we have Tech Explorer AI. So this is one of my friend, Metal, that's doing this. It's really good. If you want to learn about AI, we're obviously a big fan of Google AI blog, and we listen to AI Unleashed and the AI breakdown as far as contents. I just wanted to conclude this workshop / presentation webinar with you guys. And I think what has been amazing over the last 10 years is essentially we're in a world where now we consume data science, right? And it's cheap compared to what it used to be. It's faster because you have all these tools that are available. And most of most of people basically are doing are living in that space, which is they consume and then they use data science today, right? And all these things are already pre-built for people, right? So that's something that is new, and that unleash a lot of things. You know, like you hear a lot of like doomsday scenario about, oh my God, your job's going to be automated. You know, your industry is going to be impacted. Yada yada. Everybody here on the left-hand side is becoming a data scientist. This is really not true, right? I mean, like what is really changing is AI is becoming democratized, right? There is a model for that. Like there was an app for that with the iPhone. The LLMs are becoming standard to every application. And then you're really coming from a world of building models to consuming models. And what really changes is this for me, right? That's what we observe is not everybody is becoming a data scientist, but everybody consume data science. And that's a big change, right? Building new company will be cheaper and faster because you literally have so much more efficiency with the tool you use and with Gen AI, making just developer more productive. And I think the biggest threat out there is if you have an existing business today, you know, like somebody reproducing that business gonna make it it's gonna be even easier to enter that market, whatever market you're in. You know, whether it's healthcare or e-commerce, doesn't matter. Like the barrier to entry will, and I think that is a wake-up call, right, in some way. So that's the end of this session. Next time, by the way, we will talk more about Gemini. But do we have a Q&A? Did it work? I think we didn't make the Q&A work. But Nicolas, I don't know if you have, do you want to ask a question here? I think we haven't allowed, there's some restriction on the basically speaking. So I think, Nicolas, we're going to take your question offline if you don't mind. But this ends the session. Give us some feedback. We'll ask you to fill out a survey after this. To see to hear what you want to see and so forth. But I think that ends the webinar for today. So thanks everyone, and we'll have some more webinars later during the year. I know that we have a bunch in Paris and London, so we look forward to see some of you there. Thank you.